Today we're told a town's population has been increased at a constant rate. In 2010, the population was 46,020. By 2012, the population had increased to 52,070, and assume this trend continues. We need to now predict the population in 2016. All right, so why don't we take a look at this? Imagine you create like a little table for yourself, right? So imagine we have maybe the year on the top. It doesn't really matter. Let's say we're starting in 2010. Why is that 2100? I don't know. Let's say we're starting in 2010, and the population is starting with 46,020. Let's now say in 2012, right? Maybe I'll leave a year separation here. So maybe in 2012 now, the population has now increased to 52,070. And what they want to know is hey, if this trend continues, what's going to happen in 2016? Okay, 12, 13, 14, 15, and then 16, okay? So, how can we figure it out? Well, can I figure out how much the population is changing per year? I forgot the zero there, I guess. Can I figure out how much the population is changing per year? Yeah, right? And you're probably like, looking at this, yeah, I can figure that out, right? If the population is this at a point in time that is 2 years later, right, than 2010, and I know the population at that time as well, then I can figure out the per year change in number of people. In other words, you simply take the difference, the 52,070, and you minus then the 46,020. And then you divide it now by the change in the number of years, or the time period, right? 2 years pass. You could have simply now plugged in the 2012 minus then the 2010. And wait a minute, is this y2 minus y1 over x2 minus x1? Well, by gosh, by golly, it is, right? This is the slope formula. So what you're doing is you're calculating the slope. So let's do it. 52,070 minus 46,020. Then divide that now by 2. So 3,025. So it seems to be that the population every single year is increasing by a value of 3,025. 3,025. So what's the population? Now we can fill in a couple of things. What's the population in 2011? Well, the population is going to be now 46,020 plus that increase, 3,025. So we get a population now of 49,045. And then it's going to increase by another 3,025. So take the 49,045 and add then the 3,025 to it. Oh, wait a minute. That's already what we have. That should make sense. Hopefully that's the case. Right? And now what you can do is you can keep repeating this process if you wanted until you get to 2016. Or what you can do is you can now realize that we have 1, 2, 3, 4, 5, 6, right? Well, there's also 6 years between the two, so you could figure it out that way. But we have essentially 6 population increases of 3,025. So how many people would we have accumulated over that time? Well, it would have been 6 times then the 3,025, right? And the amount of people that we would have accumulated, so to speak, in our population would have been 18,150 people. Okay? Now, is that the answer? No, that's not the answer. We would have accumulated this number of people. We would have to then take it and add it to now the original starting value of 46,020. And when we do that, guess what we come up with? We come up with our answer. 64,000. Oh, what happened there? 1 second. Oh, 64,170. So that now is, my friends, the value. 64,170. Okay? All right. So that's the answer. Now, this is one way to look at it. If you take a look at the prior video I did, basically same question, just talking about decreasing, check out the playlist, the modeling with linear functions playlist, and just take a look at the problem before. I explained it very differently. And the reason why I explain these questions differently, and you might want to check that out even if you're not doing it, is because there might be another method that might connect better with you, right? You might understand a different method better. There's so many different ways I can explain this. And obviously I don't I would love to get to know you, but I don't know how you learn in particular. So what I try to do is I try to explain things in a bunch of different ways, and hope the random process of me explaining it in different ways combined with the random process of you finding a particular video one time or another will click. All right. In any case, I'm going to move on to the next one. So identify the year in which the population will reach 75,000. So what we can now do is, so this might be a little harder to think about it through a pictorial way, using a table, but we can kind of do it still. We can do it. It's just harder to check. What might be easier at this particular point is to try to come up with a linear function, all right, in order to solve this problem. So what we are going to do here is I'm going to write something like this. I'm going to write y is equal to mx plus b. I know I'm dealing with a linear function because it's talking about a value increasing or changing at a constant rate. So that is keyword, or that's key phrase for linear equation. Now, in order to create this linear equation, I leave the important features that define a linear equation are the slope and the y-intercept. So I know now I have to get a value for my slope and then get a value for my y-intercept. Okay. Now the slope, didn't we already calculate that before? Didn't I mention that the slope is 3,025? So we already know what that is, right? So I'm going to now plug that in, 3,025. But now the question is, well, what the heck should I plug in for the y-intercept? The y-intercept you can always think about as the value that you're starting with, or that it starts with. Okay. Now, there is some flexibility to this, but what I would do is when I would look over the question, I would just assume that this problem starts at 2010. Obviously, the year, right? Obviously, it doesn't start. The population didn't just all of a sudden, boom, it was 46,020, right? What happened before that? But let's just assume we start the problem at this point. Okay, this is the initial start. So whatever the value of the population is at the start will be your y-intercept. So in other words, I'm going to now plug in the 46,020. Okay. Now, with this model, with this linear equation, what this is now is the y value will tell me the population. And the x value will tell me, or the x value is, or it would tell me depending upon what I plug in. But the x value now represents, and just like the y value represented the population, the x value now represents the time elapsed from 2010. It does not represent the year. It doesn't. Okay? You cannot go plug in the year of 2020 and you'll get an answer, but it's not going to mean what you want it to mean. So you have to be very careful with this. Okay? So what I'm going to do here is it wants me to identify the year. Now I can find the time elapsed to then help me identify the year. Okay, but what I get as an answer for this will not be the overall answer. It's going to help me get there though. So watch what I'm going to do. They told me the population here is going to be 75,000 at some future point in time. So I'm going to plug in the 75,000 for y. The 3,025 stays the same, and what I'm going to do is I don't know what my x is, but you know what? Wait a minute. If I just plugged in that y value, notice how I have everything else in this equation. So what that means is that I can solve for x now. Anytime you have an equation with only one unknown, guess what? You can solve for that unknown, and you should, okay? Because anytime you can find out more information about something, it's probably a good thing, right? Even if the new information is hurtful. It might be good to have more information rather than none, right? Life lesson. Anyway, so 75,500, not 70, yeah, no, what am I doing? 75,000. 75,000. What we're going to do is we're going to subtract now the 46,200 from both sides. I'm solving this for x, remember. So minus 46,020. So it comes out to be about 28,000, sorry, 28,980, if only I could read a calculator. So 3,025 multiplied by then the x value, okay? Now what you're going to do, since I'm running out of space, I'm just going to divide both sides by 3,025, okay? So divide it by 3,025, and we get an answer of about 9.58. All right, now, what does that actually tell us? So let me just shrink this down a little bit. Uno secondo. All right, so our x value here is going to be a 9.58. Now this tells us the amount of time that has elapsed, or the number of years, right? When I say time, how do we measure time? I should have said years elapsed, okay? Because that's the time period that we're talking about in the problem. So this should represent years. Years elapsed, all right? Okay, so now if we started in 2010 and we elapsed, or over that period we went 9.58 years, the question is then, in what year are we in, right? What do you think? What would be your answer? We would be in the year 2019, right? We would be in that year, okay? We don't round this value up or anything like that, because the nature of the question is it's asking us what year are we in. So we're in the year of 2019. We round down in this particular case, okay? Because that's what the question requires. But that's how you would answer it now. So the year in which the population will reach 75,000 is going to be 2019. What point in the year? Well, it's going to be a little more than halfway through the year. Now, if they wanted to get more specific, we definitely can. We got numbers right. Numbers are very useful. So anyway, guys, that takes care of this. Thank you very much for tuning in. I do appreciate it. If this video helped you out at all, give us a hand. Tell your friends. Hit the like, subscribe. You know what to do. All right. We really appreciate it very much. We got thousands of more videos out there for you just to help you through your classes. Check them out. Thank you very much.